Yeah, welcome. Let's continue. We were talking about the structure of propane and butane. Propane prop, we will be having your C. That's the best way to start. Start with the connecting the carbons. There are connect three carbons, and then now make sure that every carbon is surrounded by 4 bonds. In this case, because it's a hydrocarbon, therefore the remaining bonds are for only hydrogens. Fine, this will be the case. And then the condensed structural formula of propane will become CH3 CH2 CH3. That is the condensed, whereas the molecular formula will be just C3H8. Fine. Then we go to butane. That's where now very interesting thing starts. Butane, 4 carbon atoms. I will have 1, 2, 3, 4, and 1, 2, 3, and then 4 in this case. And then every carbon should be surrounded by 4 bonds. Every carbon surrounded by 4 bonds. And this is the case. Fine. Science is becoming fun now. We play with the carbon and hydrogens now. So this we can connect and still form a but. In this case, but. Fine. But now, here we have got 4 carbon atoms. The condensed structural formula will be CH3, CH2, CH2, CH3. Very interesting. Some learners can say also this is okay. I can write CH2 times 2, just the multiple of CH2, and then CH3. Also this one is okay, very clever. And in this case it will be CH3 CH in brackets CH3. I think you get the difference between this one and this. This one now is a branch. This is just multiples of CH2 and then CH3. The molecular formula will be C4H8 H10, and then also this one will be C4 carbons. There are hydrogen 3 7 plus 3 is 10. Now can you see, now we have got 2 compounds now. This is butane, C4H10, but are we still going to call this one butane? No, it's not the same as this one. Therefore, but they've got the same molecular formula, and the 2 compounds have got different structural formula. Therefore, what is the name of those compounds? Compounds, come the new concept now. Compounds with the same molecular formula, but different structural formula. This type of compounds have got special name, which is they are called structural isomers. If you still remember in grade 10 when we were talking about the isotopes, so iso, the same. So in this case now they've got the same molecular formula, but they differ in terms of what? Structural formula. So such compounds with the same molecular formula but different structural formula, they are called structural isomers. In this case, this is not butane, but it will be called 2-methyl propane, or some clever learners can say it's just methyl propane as well. This is also acceptable, just to call it methyl propane. I hope we are clear here on this one. That's the mean that isomerism in alkanes. start with C4H10. If you go to C5 as well, you will have almost even 3, because you will have 1, 2, if it's C5, 1, 2, 3, 4, 5, or 1, 2, 3, 4 branch, or even 1, 2, 3, 1, 1. So this is your part of your knowledge. Go and check how do you draw these 3. They mean that now the C5H12 will have these 3 structural isomers. So the 3 structural isomers, now we call them structural isomers. We'll classify them beyond structural isomers in the next few topics, next sections that we'll be talking about. Now let's go to alkenes. Very important one, alkenes as well. Alkenes, you said they end up with an "ene." All alkenes end up with an "ene." Once you see "ene", then it's an alkene. The first member of alkanes was methane, but the first member of alkenes will never be methane. I hope you know why methane, because we cannot show what double bond in a methane. There's only 1 carbon. Therefore, the first member of alkene will be ethene. Ethene. So eth will have 2 carbon atoms. The "ene", there's a double bond, and then the remaining bonds will be for hydrogen. Remember, alkene is still a hydrocarbon. The condense will be now CH, CH2, CH2, and the molecular becomes C2H4. I hope you can see that. If you go to next one, you will find that the next member beside this one will be propene. Propene, prop, 3 carbon atoms, 1, 2, 3, and then all the carbons should be surrounded by 4 bonds, not more, not less. 1, 2, 3 for the first one, or there should be a double bond somewhere. Yes, 1 bond here is enough, 1 bond and 2 bonds. Now you can see this will be CH3 if we represent in condense, CH and CH2. Molecular will be C3H6. The other one that also now start to be complicating is the butene. We don't have compound called butene in this chemistry because there are many ways of expressing that. You can have 1, 2, 3, 4, 1, 2, 3, 4, or 1, 2, 3, and then 4. My double bond here is carbon number 1, or double bond can move to carbon number 2, or just at carbon number 1, but now with a branch. All these 3 compounds will have the same molecular formula of C4H8. You see the trends. So number of hydrogen is double the number of what? Carbon atoms. We can even create, say, now therefore the general formula of all alkenes, will be now CnH2n. So this is the simplest one. The number of hydrogens is double the number of carbons. Now if we continue with this and say, now let's continue. We say the general formula is CnH2n of all alkenes. Now the butene, which we don't have, we have to now specify according to the functional group. Then this is the first option of drawing C4H8. The second option will be this one of drawing C4H8, H8 hydrogen, 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 and the last option is this one of drawing C4H8, 2, 3, and then this one as well. Now we've got C4. All of them have got C4H8. But now, will they have the same name? No, they don't have the same name. How do we name them? the first one becomes a but 1-ene, or some people they call it 1-butene. Is fine. That is the name of the first one, but 1-ene or but 1-butene. The second one, if this one is but 1-ene, the second one you can now even know how to name it, becomes but 2-ene, or is called 2-butene. That is the name of the second one. The third one will be, now remember the 3 carbon atoms are prop, but we have got a branch in the propene, therefore we will now say the branch is at carbon number 2, therefore which means that becomes 2-methyl propene. People which love the numbers, they can call it 2-methyl prop 1-ene, or some people can say, I know it's the same, please just call it methyl propene. I think you understand it now. Isomerism in alkenes also start with C4, but this time around is C4H8. You can see now the isomerism stuff in alkenes, isomerism stuff in alkanes. So that is in a nutshell how do we name this one. You can play with the C5. C5 will have only again 2 here. Let's see, 1 2 3 4 5. You can have 1 2 3 4 5, and then we can also have a branched one. I think this will be the case. We can't have that one of a cross in this case, so because of the double bond. So we'll have only these 3 options for C5H10. So if you follow this of CnH2n, therefore the number of hydrogen is double the number of carbon. So this one, the double bond can be at carbon number 1. This one, the double bond can be at carbon number 2. So this one, the double bond can be at carbon number 1 only. That's the only option. I hope you understand it in this case. So, or the double bond can be at carbon number 2. Let's see if we draw it differently, and now have this double bond here at carbon number 1 again, but the branch is at carbon number 2. Here the branch is at carbon number 3. So that's how it's going to be. So this will become the 4 isomers of C5H10. So we'll talk about the naming of this in detail in the next session of dealing with the how do we name compound following the UPEC naming rules. For now, that's okay. Thanks.